listen to us. So I'm going to pick up the conversation kind of at the Sturm and bathtub dynamics step. So if you haven't come across this before, it will be a whirlwind introduction to it, and if you're well versed in it, hopefully we can look at your mental models of the problem. So I was, as part of my PhD, looking at how we can help students to overcome what we call stock flow confusion, where they think that a stock is a flow, and accordingly they decide that the action is sort of the wrong action to take. So some definition, in case you're not familiar with the terminology. So a stock is a term for any entity that accumulates or depletes over time. And a flow is the rate of change of that stock. So a good way of thinking about it is the camera test. If you take a picture of it, it's likely to be an accumulation. If you need to video it, you're likely recording a flow. So one of the tests that we give our students at ANU in our systems thinking course is to think about, well, are these things stocks or flows? So I've got 4 examples here. And maybe for 20 seconds, just in your own mind, have a think about each of these things and whether you think that they're a stock, so there's something that you can take a picture of, or are they a flow? Are they something that you would record over time? Just 20 seconds by yourself. I'm hoping as people who think in systems and as policy thinkers that perhaps you've got 4 out of 4, but just in case you haven't, maybe if you could talk to the person next to you and just check your understanding. If you haven't met the person next to you, say hello, and then check your understanding. Okay, if I do some cold calling, what will happen? Gross domestic product, is this a stock or a flow? Somebody over here? Everyone's a bit scared. Sorry? Okay. We can start getting philosophical. And we should absolutely get philosophical, but in the terms of maybe gross domestic product versus gross national debt. The measure of flow of money through the economy versus the amount of money that the profit and loss. This stuff isn't easy, and this is really, really basic stuff. Population of a country, stock or a flow? Good. Okay. Water in a reservoir. Yeah, but again, it depends on whether you're, yeah. And people leaving a department store. Excellent. So we asked this question in the first week of our systems thinking class. These were the results from last semester. These are 3rd, 4th year undergrads. They've all done first year calculus. They should understand the difference between they should understand their calculus. So we've got what I would probably say is evidence of some sort of confusion around things. Perhaps it's in the description of the experiment. So perhaps there is some confusion around terminology. Perhaps, like when you think about gross domestic product, you could think of it as a succession of stocks, perhaps. And perhaps there's a bit of wiggle room around some of these terminologies. But there is a bit of confusion. And so when you start presenting really big models, but fundamentally we're not sure whether things are stocks or flows, I think we can start to run into a bit of a problem. So continuing on the line of Sturman's work, this was a classic example about greenhouse gas emissions into the atmosphere that he gave his students now, I think 15 years ago, around what do we need to do to level the amount of carbon that goes into the atmosphere. I've simplified it. I've removed the greenhouse gas element because it really just is a stock and flow question. But trying to get students to think, okay, well, if this is the level of stock that we want to achieve, if this is the level of accumulation, what do we need to do to the flow in order to achieve that accumulation? So remember, a stock is something that accumulates over time or depletes, and a flow is something that adds or takes away from that flow, from that stock. So again, maybe with the person next to you, if you can have a think about what action you would need to do with the flow rate over time to achieve that sort of behavior, that shape of behavior. I'll give you 30 seconds. All right, can I get a bit of an airwave from the group? Right. Hey, I think we're doing pretty well. We're down like this. Looking good. There were a few, but down like this. So this again is a very, very simple question about stocks and flows. It's non-linear, so perhaps it's a bit more challenging, but it isn't. It should be something that if systems are intuitive, we should be able to understand immediately. So yeah, with these different trajectories, one common thing that we see, and Sturman saw, was what they call the correlation heuristic, which is that top line, or perhaps the second top line, depending on which the extent, where people think that the behavior of the flow should mimic the shape of the stock. Of course, the correct answer is to get to zero as quickly as possible, slowly as quick as possible, to stop that accumulation going up. So some ideas around this. So I suppose we've got some evidence that suggests that people don't get these questions right straight away. And I've been looking at ways that we can help students to orientate their mental models so that they get these correct more quickly. Because as I said, as you build into more complex systems, you need to really understand the difference between the stocks and the flows. So we know that systems thinking is intuitive, and there are lots and lots of leading thinkers who say this. So Forrester talks about any child who can fill a water glass or take toys from a playmate knows what accumulation means. If you had any experience with a bathtub, you understand the dynamics of stocks and flows. From the cognitive linguistic perspective, we also have an understanding of the world around us because of our interaction with the world around us. So our experience with physical objects provides the basis for a whole range of metaphors that we can use to understand different systems, which I suppose is the example of the bathtub metaphor. From learning theory, children learn to speak and learn the intuitive geometry needed to get around in space, all without having been taught. And so there's lots of evidence that suggests that this is something that we intuitively understand, but for some reason we get caught up with, especially with the testing that we've been doing at the undergraduate level. Perhaps one of the reasons why understanding stocks and flows is difficult is because of these graphical representations. So some of the ideas that we're working through at the moment with some of my honours students is around how we represent stocks and flows. So if anybody's ever used VenSim, this is what a stock and flow representation might look like in VenSim. You have a box that represents a stock, which I suppose is a bit like a glass or a vessel being filled. You have some sort of flow in, and that's represented by this funny triangular shape, which represents a valve or a tap. And you have these feedback loops in blue. The clouds either side represent things that we're not concerned about, so they're things outside of our area of interest. The bathtub metaphor, so this is taken from the tests that Sweeney and Sturman did around trying to help students to think about, well, okay, stocks and flows are a bit like having a bathtub. You flow in and you flow out, independent, but are controlled by taps. One of the things that's interesting about a model like this is that the taps, if you think about the way that you use a bath, you turn the tap on, it flows, there's no energy required for that water to flow into the bathtub. There's energy required maybe to turn the tap, but it happens automatically. In this case, it's a bit strange also to see a tap at the other end of a bath. Normally we have a sink or a plug hole, a drain, I suppose. And that drain, if you want to look at the physics of the bathtub, people can start building in things like the mass of the water above the speed that the water would exit the drain. And so sometimes, like when you think too deeply about the metaphor, the mapping disappears a little bit and becomes less useful. So I've seen a number of forum threads get lost in, well, you're not accounting for the volume of water that's in the tub and the rate that would change according to the amount of water that would be there. And it kind of misses the point. The intuition, the simple level of the intuition is around understanding the difference between the rates and the stock. At the other end, we've got some new software that's coming out. This is a piece of software developed by a company called BTN with the Creative Learning Exchange, who's trying to use liquid physics to try and help people to understand stocks and flows. And I'm not I'm not quite convinced, but for some reason they've chosen the lever as the representation of the control of the flow. And I think that the lever has a whole range of metaphors with it around policy. So you pull the lever and watch the machine turn, those sorts of ideas. The lever for me doesn't have a lot of control. And so if you think about the way that you use a lever, it's typically on or off or into a gear, perhaps. And so there's a range of metaphors that are tied up with flows controlled by levers. But it's an interesting development. They're trying to use this in primary schools to try and help people to develop that intuitive understanding of how flows add and subtract to stocks. In Barry Newell's book, Understanding Human Ecology, he chose to use pumps on the inflow and the outflow to represent the way that you might control the flow in and out rather than taps. And this is quite useful in terms of decoupling that idea of the gravity and the water pushing out. And so using the pumps allows you to control it a bit more. And I suppose where we've been at is to take that idea one step further. And so, and using an activity that Barry developed as part of a program that he had with local farmers to try and understand stocks and flows on in their land use. Actually trying to get students to take the role of the kinetic action of using the pump. And so rather than sitting back and controlling pumps, where you might just use a little dial to say this is how fast it's going to run, actually get students to start embodying the flow rate so that they can then go, oh, okay, I can see that flow requires work. It's something that takes time. It's something that happens over time. And it's something that if I want to add to, I need to go a bit faster. If I want to slow down, it becomes, I become a bit slower. So we did this with the atmospheric carbon stock question that I presented earlier. And we had this activity where we just got a whole range of students with a whole range of different prompts over a number of years to play with this pump set and see what happened. And what we found was that it wasn't actually very, very useful for helping people do the test. So that test that we showed earlier, it wasn't ultra useful for that. People did a little bit better than they did in the results reported by Sturman. But nothing that you'd say, okay, this is the way that we should be teaching system dynamics. But what did start to happen is that the conversations became a bit more orientated. So people were able to start seeing what they did in the activity, and then 4 or 5 weeks later, they'd come back and they'd be going, okay, well, in this activity, we had 3 actors and they were pumping, and they'd start to go, oh, when we start thinking about when we compete against each other in that archetype, it's like us going faster and faster with the pumps, and we keep going and it's not going to go anywhere. And eventually, one of the best ways to get out of that archetype is to stop. And so they were using the pumps later on as a way of thinking through the problem. And this is where I'm going to tie back to mental models. So this, again, comes out of Sturmer's textbook. It's a description of how a double loop learning process works. So often, if in a single loop, the red section isn't there. And what you do is you have a mental model of the world. You use that mental model to dictate your decisions or your strategy that feed your decisions, and you make an action. Something happens, your plan comes through, and then you seek feedback from the real world. And the person who doesn't change their mental models keeps doing keeps doing the same thing, or different strategies that are bound to the same mental model, but gets the different feedback back. It's not quite right, things aren't working. Somebody who can change their mental model might observe what's going on and go, actually, am I thinking about this the right way? Am I thinking about this the wrong way? And perhaps I'm going to change my mental model, see what happens, and be a bit more flexible. And I suppose what we saw happening with the pumps wasn't necessarily that we were changing people's mental models, but we were starting to orientate their mental models. So just like the cold question that I asked at the beginning, there was a bit of uncertainty around that first one, but once you sort of got that first one, you started to go, oh, okay, I get it, I know I'm on the right track. And maybe this is what was happening in Shane's results, where that first time they did the test, it wasn't quite as good as the second time, but then plateaued very quickly. this idea that the mental model was orientated very quickly. So just a quick snapshot of one of the experiments that we did to give you a sense of how this worked or didn't work. We had that activity that I described with the picture, where people went through a number of steps, and then we asked them to draw the correct graph and write the answer, write what the pumps were doing. And when they just did the base activity, about half of them got it right, and a few more were able to write the correct answer. What we found was that when we added a group discussion, so let's have a group discussion before you draw the graph, more people were incorrect. So perhaps that was the effect of the loud person who thought that that they were right, their mental model prevailed, and they were able to convince others that what they were thinking wasn't quite right. And in the final group, we actually had cards that showed a range of possible futures, and they had that group discussion. And we found that the combination of those, while still having not like 76% correct graphs, the written responses were much better. So going back to, just to wrap things up, thinking about how we can help students to orientate their mental models as quickly as possible. The kinesthetic action of using a pump, we think led to some better orientation faster, which we think led to better thinking about systems during the rest of the course. Because you're standing up because I probably have to wrap up.
One quick question. One. Any gender differences among the participants?
How long have we got? So in the groups that we use, it was engineering class, so generally sort of 75% male, 25% female. What I think was interesting was the group dynamic. And so females did much better when they were by themselves. I think it's a problem. When the group interaction started to happen, the performance of both genders went down. So I suppose that, I don't know if that's answering your question, but I think maybe it has more to do with the group dynamics than it does the thinking through the problem.
Oh, yes.
So Chris, one of the things that's always troubled me about this test is whether the low percentage of correct responses has something to do with the familiarity of the question point. You don't get asked that type of question ever.
Yeah.
And so I'm curious whether you think the intervention that you tested here with the workbooks and the discussion had more to do with trying to help them get their head around the format of the question, because a few people may have understood it, or something else more deeply related to understanding the system again.
Yeah, so again, how long have I got? I think you're absolutely right in terms of the question itself, these sorts of formats, and you might think about this for any sort of exam. They're a different type of question, and they test a different type of learning, I think, to the type of learning that we're talking about with strategic thinking and systems thinking. And so when you're faced with a question like this, I can understand why a lot of people get it wrong. And I think that this whole area of stock and flow confusion isn't actually stock and flow confusion, it's poor test design, and it's poor pedagogy. And if we're able to overcome that quickly, I think we could test it in a much better way. And so one of the points that I've got to supplement that idea is this idea of the difference between the written description and the graphical description. And so often, say this 93% group that got it correct, they were saying things like the pump needs to stop, but they had drawn a graph that went like this. And so they had the correct thinking about how it would solve, but they just didn't have the graphical literacy in order to answer the question correctly. And so when we actually boil down to people who drew the wrong graph and had the wrong written description, you're talking about 5%. And I think that there's the confusion in itself is just with the format.